Welcome to PanLab Podcast. Continuing our series on stress after talking about different types of stress, the good stress and the bad stress, and the crucial stress response of our brain, making our body mobilized in every manner. We come to a very important point in this whole discussion, that is chronic long term stress and related diseases. So, we'll be talking about cardiac arrest, sudden cardiac arrest or heart attacks, hypertension, and the differences in the personality and gender related to the stress response and the way our body really manages the stress. More importantly, we're also going to discuss about that how actually we can deal with this scenario of long-term stress which has simply become a part of our life. Like, I cannot tell you to get rid of a child that is giving you trouble, or I cannot really say that, oh, your parent is terminally ill and you shouldn't be stressed about. It's futile to say things like that. Stress is inevitable, and sometimes we are in such a situations in life where we cannot do anything about it. We cannot control it, we cannot eliminate it. So all we can do is that we can simply try our best to manage it, deal with it at best of our capacity, or somehow just enhance our capacity to deal with it. And also have this kind of a sense within us where we are able to differentiate what sort of stress is worth paying attention to or letting your sleep go haywire for, and what's not. Hypertension or elevated blood pressure. Now, we know that there are two numbers in measuring a blood pressure, the upper number and the lower number. What is the significance of these numbers? Now, the upper number is actually your systolic pressure, and systolic pressure reflects the force with which blood flows from heart to rest of the body. Then we have got that lower number which is called diastolic pressure, and that reflects the pressure or the force with which blood flows back to the heart. Now, the ideal blood pressure is 120 by 80, and if you have blood pressure which is more than 140, that is your systolic pressure is more than 140, and diastolic, which is the lower number, is more than 90, then you fall into the category of elevated blood pressure. The problem with the elevated blood pressure is that, as the name suggests, it is increasing the force with which the blood is coming from your heart and then going back to your heart. So it's not only putting pressure to the various blood vessels that carry blood from heart to rest of the body, but it's also putting pressure on your heart back when the veins carry back that blood to your heart. So this is the first thing that goes wrong when we are exposed to chronic level of stress for a very prolonged time period, under which your body somehow loses its functionality and its capacity to effectively manage the stress. It's only going to be that when you are exposed to such a long phase of stress every now and then and on a frequent and regular basis, and your stresses are equally acute. At the same time, your body's defense mechanisms, the way of attacking and dealing with the stress, is also impaired or hampered due to various other reasons that we're going to talk about. Now, what happened is that it's a very vicious cycle. There are blood vessels which are distributed throughout the body, which do the work of circulating blood and making sure that each and every organ, tissue, muscle, cell receive sufficient oxygen and nutrients. So that's the work of blood vessels. Now, what happened when, due to stress, there is an activation of sympathetic nervous system, and that triggers the whole flow of blood to be more damaging, to be more apparent. You could say that it's more forceful flow of the blood. And in that scenario, the toll is taken by these blood vessels whose work is to circulate blood and making sure that all the nutrients and oxygen reaches the required cells, tissues, and organs. They are very delicate. So they take this excessive flow of blood pressure because your heart is pumping out faster under stress. They take that excessive flow like a tsunami, like a turbulence. And when you keep on doing that, when you keep on subjecting yourself to a chronic stress and you have a chronically elevated blood pressure, and this goes on and on and on for a very long time, what will happen eventually, that these blood vessels and the point at which these blood vessels gets divided into even smaller blood vessels to reach out to each and every cell, that point of division, the point where it divides, the point where they're connected, that start getting damaged, that started getting injured. And that happens directly due to the stress and the effects of the stress response, and when they are being done chronically. Now, it doesn't just stop there. It's not just that your blood's capacity is being compromised because of the damage of this impact of excessive flow and pressure. What happened, in order to recover from that pressure, or in order to take that forceful flow of the blood vessels start growing extra layer of muscles around it. Hence, that makes your blood vessels even more rigid, even more hard, even more resistant to flow. So now the space is even more narrow for your blood vessels because it has created this covering of an outer layer of muscles it has in its inner walls. So now there is even less space for your blood to flow. So the pressure at which that blood will be coming is going to be even more. So compounding effect. So now you have got yourself chronically high blood pressure because now your damaged blood vessels have created that outer covering, which makes the space even more narrow for the blood to flow. So now the pressure is even higher. So you fall into that category. Now the problem is blood is returning to your heart. That is also being compromised. It makes a great impact on your heart's muscles. When the blood flow that is returning to your heart, that is going back to your heart, also hit it with a lot of pressure. So the muscles also take the toll of it. And as a result of which, even heart grows an extra layer of muscle in order to protect. And that's called left ventricle hypertrophy. It simply means that there is increase in the mass of the left ventricle of your heart. So you could say that a left portion of your heart, there are extra muscles now, extra mass. Now that extra mass and muscle makes your heart overdeveloped and loop-sided because it's heavier only on the one side and not on the other. And not only that, this extra mass requires more blood flow than your arteries can supply. Now, even lesser blood is coming to the heart, lesser oxygen and nutrients are coming back to the heart than previously because of the development of this extra mass, and that was the result of the stress that you have been taking for a very, very long time period. Apart from the age, this left ventricle hypertrophy is one of the main predictor of heart attacks. So hypertension itself is not good for your blood vessels. It not only damages them, there are more things happening there. And now we come to the talking about the role of cholesterol, specifically your so-called bad cholesterol or LDL, which is your low density lipoprotein, and other kind of various fatty acids and glucose that has been circulating in your bloodstream as a result of a stress response. When your brain activates stress response, it makes the sympathetic nervous system alert, and that triggers the release of epinephrine, norepinephrine, and then eventually glucocorticoids also get released by adrenals. And what happens? Epinephrine specifically mobilize these fatty acids from the fat cells, proteins from those muscles where it's not needed, and the glucose, which is the simple form of sugars, into your bloodstream in order to provide enhanced energy and oxygen supply to various organs that will be needed in order to fight that particular stressor. Now, while doing that, because of a chronic stress, you have a damage of your blood vessels. As soon as the blood vessels get damaged, there is an inflammatory response. Inflammation will happen, your body will react to it, your immune system is going to send certain cells to that injury site of blood vessels for the repair, right? Now, when it does that, due to the release of epinephrine in your bloodstream, there is going to be mobilization of this fat, LDL, and platelets. Platelets is a protein in your blood which is responsible for creating these clots. And clotting of blood is also necessary because if your blood is not able to clot to a required amount, then there is a risk of internal bleeding not stopping, or if you bleed and you get an injury or a wound and the blood doesn't stop because the clotting protein, that is platelet, is not working fine. So epinephrine is moving this platelet, these LDL, which is the bad cholesterol in general terms, to the site of blood vessels where the injury is. So now you have damaged blood vessels, and around those damaged blood vessels, fats, glucose, platelets come and they start aggregating. They start forming a plaque over it, like the plaque that gets formed on your teeth. So what's happening then? It's making those vessels, it's making those arteries even more harder, even more rigid to carry that blood, to carry that extra force of the blood. And that's what leads to this disease called atherosclerosis. Atherosclerosis means hardening of blood vessels, hardening of arteries. Arteries are those blood vessels which carry blood from your heart to rest of the body. So release of stress hormones creates plaque, this gunk mass around these arteries, these blood vessels, which are already damaged, which are already compromised, making them hard, making them hard enough that if you keep on going through enough stress. So now you have atherosclerosis. Once you know that you've got atherosclerosis, it's even more riskier for you to take any amount of stress, because any amount of stress is going to make those clogging even more hard. And once that clogging keeps on happening, eventually it's going to block your arteries, leading to heart attack or a stroke. What is the predictor of atherosclerosis, or how do we know that the risk of the cardiac or any cardiovascular disease has increased? We used to believe that the cholesterol is the main culprit, but that's not the case. Our bodies, in fact, most of the human beings can take a good amount of cholesterol, even the bad cholesterol. We can manage that, we can take it. Problem is with the damaging blood vessels. Cholesterol itself doesn't directly cause any harm. You can have a very low fat diet and a very low cholesterol and just the healthy HDL, but still you can run a risk of heart attack simply because of the damaged blood vessels. So it's your vascular damage which is a better predictor of heart attacks, and not simply cholesterol. Of course, you have to check your cholesterol because that also increases your risk. But the main thing that you have to look forward is the hardening of these blood vessels, these damage of the blood vessels, because if there is no damage, there is no injury to the blood vessel, then that cholesterol will not go and bind there. If it won't go and bind there, then it's ineffective. It's not going to create the problem. The problem is when those blood vessels get damaged, and as an inflammatory response, as a stress response, all that gunk of platelets and release of the epinephrine makes the cholesterol go and bind that injury site. And that is the problem. How do we really predict it? How do we know that there is enough damage to our vascular system and we need to be very, very careful now, irrespective of what the cholesterol levels are? That is done by C-Reactive Protein test. And I'm sure by now you would have heard about C-reactive protein test because it has become a general trend to measure it in your blood work. C-reactive protein is a protein made by your liver and is secreted on the signal of injury in your system, injury to your blood vessel. So when your brain send a signal of inflammation, when it sends a signal of any sort of damage, any sort of injury, any sort of wound, or any sort of infection attacking your body, on receiving that signal, the C-reactive protein is being secreted by your liver to fight it out, to combat all these problems, all these threats to your body. So higher the level of C-reactive protein in your blood indicates there is a high level of inflammation, high level of damage happening inside your body. And that is a better predictor of cardiac arrest than cholesterol. That's why it become a general phenomenon now to measure your C-reactive protein in your blood work. Thank you so much for listening to Panlab Podcast. I'm Akansha. I'm a psychologist and an independent researcher. Thank you for giving your time to science and psychology. If you like what we are doing here, the information that we are providing, the knowledge we are trying to spread, if you like that, please show your support by subscribing and sharing it to the people who might benefit from this kind of information. Thank you.